Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we're going to be focused on Unit 4, Lesson 7. Our main topic is graphing polynomial functions. Don't forget to put your first and last name, period, and the date in the upper right-hand corner. And then our objective today, I realized has some typos in it, so we're going to fix that. Our objective is I will identify and graph key features of higher degree polynomial functions algebraically. Mastery will be demonstrated by scoring at least 80% on today's homework. So again, instead of an extra practice today, we're just going to jump into our homework. Your homework is a worksheet, once again, found on Schoology. So today you're going to learn how to graph like degree 3, 4, 5, 6, etc. Polynomial functions. Our last few lessons were focused on degree 2 or quadratic functions. And when you graph higher degree functions, the steps are a little different than our degree 2. So that's what we're going to focus on today. This is just a reminder of the end behavior of polynomial functions. Remember, you look at the first term. If the first term is positive and an even degree, your end behavior is up and up. If it's negative and an even degree, your end behavior will always be down and down. If your degree is odd, but the leading coefficient is positive, then your end behavior is down and up. And then if your leading term is negative and your degree is still odd, then you're going to have up and down as your end behavior. So this table is just a little reminder for us because identifying our end behavior first is actually going to help us with graphing these higher degree polynomial functions. All right, so our very first equation is p of x is equal to x cubed minus 12x squared plus 35x. Now remember, p of x or f of x is just function notation. It replaces the y. P of x is just a way of saying this is a polynomial function. So the very first thing we're going to do is we're going to identify the end behavior. That's step one. So remember, you look at your leading term, and our leading term of this function is x cubed. Well, this term is positive and the degree is odd. So my end behavior will be down and up. And remember, we described the far left and then we described the far right. So this graph will go down to the far left and it'll go up to the far right. And that'll come in handy in just a second. Now for step 2, we want to find the x-intercepts and graph them. So our equation is p of x is equal to x cubed minus 12x squared plus 35x. So the first thing we want to do is make y or p of x 0. Then the next thing I want to look for is, can this be factored? Well, x cubed, negative 12x squared, and 35x all have an x in common. So I'm going to factor that out of each term, and I'm left with x times x squared minus 12x plus 35. Then we set each factor equal, or actually, we're not done factoring. X squared minus 12x plus 35 can be factored even further. So what are my factors of 1 times 35 is 35, 1 and 35, 2, 3, 4, 5, and 7. I think that's it. That add or subtract to get us 12. I would use 5 and 7. So negative 5x, negative 7x plus 35. I'm going to put the first 2 terms in parentheses, the second 2 terms in parentheses with the plus sign in between. Then I notice x squared and negative 5x have an x in common. Negative 7x and 35 have a negative 7 in common. And then these guys match, so that's one of my factors. And then the other factor is x minus 7. All right, now I put each factor equal to 0. So x equals 0, x minus 5 equals 0, and x minus 7 equals 0. So x equals 0, there's nothing to solve. This one we're going to add 5. This one we're going to add 7. So my x-intercepts are at 0, 0, 5, 0, and 7, 0. I found 3 x-intercepts. Remember, this polynomial was a degree 3, so I should expect to have found 3 x-intercepts, and it looks like I found all 3. 1, 2, and 3. They're all real numbers. They're all graphable. So let's label our graphs real quick. If you need to hit pause, do that. Remember, you need to put a dash at every, where every number would go. And then we're actually going to wait to label, or no, never mind. Ignore that. There are going to be some polynomial functions where we aren't going to want to count by ones on the y-axis, which is fine. We can count by like literally whatever we want, tens, hundreds, thousands. And we're going to have to wait a minute to figure out if we need to change this, but for now it's fine. So I'm going to graph my x-intercepts at 0, 0, sorry, 5, 0, and 7, 0. All right, so what's kind of cool though is I know that these are all 3 of my x-intercepts, right? So I know that I'm not going to cross the x-axis any more times than these 3 times. And I'll talk about how we're going to use our end behavior in just a second. But to help us graph, I actually want to do step 3 and then step 4. After we find our x-intercepts, we also want to find our y-intercept and graph it. So remember, whenever you find a y-intercept, you always use x equals 0. So we're going to take y is equal to x cubed minus 12x squared plus 35x, and we're going to plug in 0 for x. So 0 cubed minus 12 times 0 squared plus 35 times 0. And notice all of these things are just 0. 0 cubed is 0. Negative 12 times 0 squared is 0. 35 times 0 is 0. So we just get y equals 0. So our x-intercept, or y-intercept, sorry, is at 0, 0. So when I graph that, that turns out to be the same as one of my x-intercepts, which is fine. Sometimes the y-intercept and the x-intercept can be at the same point. No worries. All right, then the next thing we're going to talk about is finding some other points between the x-intercepts. And that's step 4. So we need to know what the graph does before, after, and between all of our x-intercepts. We want to find out what the graph does between these 2 points and these 2 points. We already know what the end behavior is like, and I'll show you how to use the end behavior and apply it to the graph in just a minute. But we need to know, like, does the graph do, I don't know, the graph could do like this between these points. The graph could do this between these points. The graph could do this, or let's say that didn't change. The graph could do this and this. So we need to figure out what the graph does between our x-intercepts. To do that, we're going to plug in some x values into the function and find the y values and then plot those points. So we're going to use a table of values in step 4 to find the points between the x-intercepts. So we want to use an x value that's between 0 and 5. So I would pick one of the middle ones. I would pick like 2 or 3. You could even do 2.5 if you wanted. I'm going to do 2 just because it's easier to deal with. And then we're going to want to pick an x value that's between 5 and 7, which would just be 6. So we're also going to use 6. So remember, p of x is x cubed minus 12x squared plus 35x. And we're going to plug in 2. So p of 2 is equal to 2 cubed minus 12 times 2 squared plus 35 times 2. And I'm just going to use my handy dandy calculator, so this will go quickly. So we're going to have 2 to the third. Just kidding. 2 to the third minus 12 times 2 squared plus 35 times 2. which is 30. Should be right. Then we're also going to find P of 6. So we're going to take 6 cubed minus 12 times 6 squared plus 35 times 6. So we're going to take 6 to the third minus, just kidding, minus 12 times 6 squared plus 35 times 6. And we get negative 6. I need to count by something other than 2's because I need to get to 30 here. So I'm going to count by 5's. So let's do 5, 10, 15, 20, 25, 30, 40, and then negative. There we go. All right. I'm going to erase these. So I'm going to plot these points. I have the point 230. So I'm going to plot 230. 230. And then I have the point 6, negative 6. So 6, negative 6. So I know that between these two x-intercepts, my graph increases and then turns and decreases. Then between these two x-intercepts, my graph decreases, hits 6, negative 6, and then increases back up to here. So these x-intercepts kind of help our graph. They like are turning points, essentially. Well, not turning points. They're the points that kind of guide what our graph does. Sorry, these would be our turning points. All right, then what does my graph do before and after my x-intercepts? So what does the graph do then to the far right? Well, look at our end behavior. Our end behavior says our far right behavior should be up. So that means that at this x-intercept, our graph continues to increase forever, which makes sense because it can't come back down because there's no more x-intercepts. It's off to the right. Then off to the far left, our end behavior is down. So I know that my graph needs to decrease from that point. So I see a polynomial function start to form here. I decrease to the far left, I get to this turning point, and then I increase. There we go. We've graphed our first polynomial function of degree 3. All right, let's try another one. So this polynomial function is g of x is equal to 3x to the fourth minus 12x cubed plus 2x squared minus 8x. So I'm going to walk you through each step. I want you to pause and then press play between each step just to check your work against mine and see how our work matches up and start to see if you can figure out some of this on your own without me. So step 1, identify the end behavior. Remember, use your leading term and tell me what this end behavior is going to be. All right, so our leading term is positive, the degree is even. You should have told me that our end behavior would be up and up. Remember, up to the far left, up to the far right. All right, step 2, find the x-intercepts and graph them. So I'm just going to rewrite my function. G of x is equal to 3x to the fourth minus 12x cubed plus 2x squared minus 8x. So the first thing I would do is factor out the GCF. And then you're going to have 4 terms, and you're going to want to factor by grouping. So I'll give you a hint to get you started. So factor out an x first. You're going to have 3x cubed minus 12x squared plus 2x minus 8. And then because you have 4 terms, factor by grouping. Put the first 2 in parentheses, second 2 in parentheses, and a plus sign in between, and factor from there. So find those x-intercepts, press pause, and then press play when you're ready to check your work. All right, so I realized I forgot to plug in 0 for g of x, so make sure you wrote 0 instead of g of x. When I factored it completely, I got x times 3x squared times x minus 4 I set each of those equal to 0. So I got x equals 0 for one answer, x equals 4 for the second. And then when I solved this equation for x, I just subtracted 2 to both sides, divided by 3, square rooted both sides. I realized I got the square root of a negative, which means that I have I times whatever that root is for an answer, which means I have 2 imaginary zeros. So we can't graph these 2 zeros. So my x-intercepts that I'm going to graph are 0, 0 and 4, 0. Yeah. So let's graph 0, 0 and 4, 0. 4. Actually, I'm going to count. I want to stretch this graph out a bit. I'm going to count by halves. So like this is 1, 2, 3, 4. There we go. So -1, -2, -3, -4. And then I'm actually going to wait to label my y-axis until we do step 4 to get a feel, step 3 and 4 to get a feel for what I need to count by. Because I'm pretty sure this graph has some crazy numbers. Okay, so we've plotted those x-intercepts. Let's keep going here. Let's find the y-intercept. So remember, you always use x equals 0. So that original equation was p of x is equal to 3x to the 4th minus 12x cubed plus 2x squared minus 8x. And we're just going to plug in 0 for all of those x's. So p of 0 is 3 times 0 to the 4th minus 12 times 0 cubed plus 2 times 0 squared minus 8 times 0. Oh, I forgot to have you press pause and then press play and find the y-intercept yourself. I'm sure you guys are really disappointed. So p of 0 is equal to, well, hey, all of these terms are times 0, so it's just 0, which matches one of our x-intercepts, which we've already have plotted at 0, 0. So we're done with our y-intercept. All right. Now for the table of values in step 4. So remember, we need to find values, x values, and plug them into the function and see what we get for y. So we have some points to plot. And because there were only 2 x-intercepts, that means that we need to just use some values between 0 and 4. I'm actually going to make you guys plug in 2 in between there. Normally, I would only make you plug in 1, but I want you to plug in 2. I want you to either plug in 1 or 2 and 3. So you can pick 1 or 2 and 3. You have to do 3 though. Do 1 or 2, and then you have to do 3. Or you could do all 3 of them, 1, 2, and 3. I don't care. Then I want you to find those y values and then plot those points. And you're gonna have to count by some crazy high numbers on your y axis, but you got this. So go ahead and find those y values, plot those points for step 4, press pause, and then press play when you're ready to check your work. Give it a shot. All right, so you may have realized that you need to count by like tens on your y-axis, which is cool, that's fine. So when I plugged in 1, I got -15, 2 got me -56, I almost said -56, and 3 got me -87, you know. All right, so I'm gonna count by -10s on my y-axis. Okay, and then I'm gonna count by 10s up here because we gotta label everything because your teacher's picky. All right, let's plot these points. So 1, -15. So 1, -15. 2, -56. And then 3, -87. So down here. So what this graph does something kind of funky, right? Between these x-intercepts. So we have to go like down, but you want to make sure it's a curve, not a straight line, and then back up to the 4. You got to come back up to that x-intercept. So basically we're like connecting the dots in between our x-intercepts, right? Then we know that our end behavior has to be up and up, which makes a lot of sense with this graph because we went down, we turned around, we came back up, and then to the far right, we need to keep going up. And then to the far left, we need to keep going up. So that would be the sketch of this oh my gosh, I almost called it parabola, of this polynomial function, the sketch of this polynomial function's graph. That was silly. All right, and then I realized we forgot to talk about the domain and range of these graphs in number 1 and number 2. So let's do number 2 together first. So the domain of this graph is, well, it extends to the far right and to the far left forever. So our domain is all real numbers. The range, however, only extends up forever. So I know that it increases to infinity forever, but it stops around -87. And we didn't find it for sure, but we're going to say it stopped at -87. It actually goes to like -87.073, but that's for a different day. All right, then for this graph, what would our domain and range be? Well, it extends to the left and to the right forever. So our domain is -infinity to +infinity. And then it extends up and down forever. So it decreases forever, it increases forever. So our range is the same. That's the domain. Okay. Let's go to number 3. So number 3 here, example 3. Sketch a graph of f of x equals -2x times 3x plus 1 squared times x plus 7 to the 7th power. So something really nice happened here for us today. Our function is already factored, so we don't have to factor it. Now, the tricky part is figuring out what our leading term would be. So to find our end behavior. So you're still going to follow the steps. So like step 1, we're going to identify the end behavior. So because there's a -2x, if you multiplied this -2x and you multiplied the 3x plus 1 times 3x plus 1 and the x plus 7 times itself 7 times, you would still end up with a negative times all of those terms, which will give us a negative for our leading coefficient. And then degree of this function is you just take all of these exponents and add them. So 1 plus 2 plus 7 is 10. So our degree will end up being a degree 10, and the leading term is negative. So it's a negative and an even degree. So our end behavior is down and down. So you take all of the exponents and just add them together, and that tells you your degree. And then we know, because we would multiply that negative through all of those terms, we are going to end up with a negative for our very first leading term. All right, now we're going to find our x-intercepts. Well, since this was already factored for us, we don't even have to factor it. We just set each factor equal to 0. So -2x is equal to 0. 3x plus 1 is equal to 0. Sorry, 3x plus 1 squared equals 0. And x plus 7 to the 7th equals 0. What this means is that this x-intercept happens twice. This x-intercept happens 7 times. Do you remember the term we used to describe an x-intercept happening multiple times? Multiplicity. So what's handy about this is that all we have to do is solve 3x plus 1 equals 0 once, and x plus 7 equals 0 once, and then we'll just say multiplicity 2 and multiplicity 7. So x is going to equal -7, multiplicity 7, because of this degree 7 here. Then subtract 1, divide by 3, and this happens multiplicity 2 because of this degree 2. Then this one is just x to the first, so it only happens once. So -2 divided both sides by 0, -2, and you just get 0. So our x-intercepts, step 2 helps us find our x-intercepts, are at 0, 0, -1/3 0, or negative what, 0.33 repeating, and then -7, 0. Then step 3, find your y-intercept. Remember, use x equals 0. So I'm just going to plug in 0 to the original function. So f of 0 is equal to -2 times 0 times 3 times 0 plus 1 squared times 0 plus 7 squared. And I just replaced all of these x's with zeros. Let's simplify. So -2 times 0 is 0. 3 times 0 is 0. Plus 1 is 1. 1 squared. Times 0 plus 7. Sorry, that should be the 7. Is 7. 7 to the 7th. Well, a nice thing happens here. 0 times anything is just 0. So it doesn't even matter what 7 to the 7th power is, because 7 to the 7th times 1 is 7 to the 7th, times 0 is just 0. So our y-intercept is 0, 0. So let's plot those points. Let's go ahead and label our axis first. And I recommend waiting to label your y-axis until you know what some of your y values are going to be. So we're going to plot our x-intercepts, 0, 0, which is also our y-intercept, -1/3, 0, and -7, 0. Oh, I said -7 and then plotted +7. That's silly. -7, 0 is here. And then -1/3, can't even like fit on this graph. Huh? It's like here. Okay. So now step 4 is you have to find x values in between your x-intercepts and plug them in to your function. So let's make ourselves a little table just to organize our work, x, and then our y values. So, okay, this is a little tricky, but because -1/3 and 0 are so close together, we're not even going to bother finding a number between them. We're just going to like connect them with a little curve. Like the amount of like change in direction that's going to happen between those two won't be a lot. So we're just going to like call it too close to count, which is fine. Then between -1/3 and -7 though, I want you to plug in like 2 or 3 values. And I recommend you do like, I would do -4, maybe -6, maybe -2. But no matter what, I would pick -4. Plug those into your function, find p of -2, find p of -4, find p of -6. Plug those into your function, and then we're going to graph all of those points. So I actually want you to press pause and then press play when you're ready to check your work. I want you to plug in -2, -4, -6, and find these y values on your own. And just as like a heads up, the numbers are outrageously big. So go ahead and give it a shot, and we'll check in with each other in just a minute. So I got 7.8 million when I plugged in -2. I got 2.1 million when I plugged in -4. I got 3,468 when I plugged in -6. So we got some crazy big numbers. So what I recommend we do is that we count by millions on the y-axis. So I just wrote 1, 2, 3, 4 all the way through 8, but I added millions by my y-axis on the positive and the negative side, just so I can tell the reader of my graph I'm counting by millions, even though it looks like I'm counting by 1. So we're going to graph 7.8 million as like, so 7,812,500 is the same as like 7.8 million, right? Then this would be 2.1 million and then 3,468. So let's plot those. So I'm going to plot -2 and then 7.8 million, -4, 2.1 million, and then 3,468 is just going to be ridiculously close to the x-axis. So this graph does something funky between these two x-intercepts. We increase and we go up to like 7.8 million, and then we start to come back down, and then we do a little curve, and then we come down to this And this is supposed to be a curve. These should be smooth in between each point here, but it just looks a little funky, which is fine. Now, we know what happens to the far left of our graph and to the far right, because our end behavior we decided would be down and down. So that means that to the far left of my most left x-intercept, I'm headed down, and then to the far right of my most right x-intercept, I'm also headed down. So our graph should look like this. And then if I wanted to, I could describe my domain and range, but I'm gonna let you off the hook for this one. All right, so now let's do, let's sketch the graph of g of x equals x plus 2 to the 5th times x minus 4 to the 3rd times x minus 8. So the first thing you're going to identify is your end behavior. So you need to identify, will the leading term end up being positive or negative? What will the degree be when you end up multiplying this whole thing out? Go ahead and determine the end behavior on your own. Press pause and then press play when you're ready to check your answer. So our end behavior should end up being down and up. And I know that because if I multiplied all of this out, my leading term is going to end up with x to the 5th times x cubed times x to the 1st. So I know that I'm going to have 5 plus 3 plus 1 is 9. And then it's going to be positive because all of these leading terms here are positive. So we'll have positive times positive times positive, which will be a positive. So I'm going to have a positive coefficient to the 9th power gives me down and up as my end behavior, which should be my end behavior. All right, so now I want you to find your x-intercepts. So go ahead and do that on your own. Press pause and then press play when you're ready to check your answers for that. And you can go ahead and graph them as well. All right, so you should have found that you'll have x-intercepts at -2 with multiplicity 5, 4 with multiplicity 3, and x equals 8, which is just multiplicity 1. So it just happens once. So our x-intercepts will be at -2, 0, 4, 0, and 8, 0. So let's get those graphed. All right, I guess I gotta label my axes here. 1 second. There is a puppy crying in the house, so if you hear that, she's fine, I promise. All right, if you hear that in the background. So let's graph -2, 0, 4, 0, and 8, 0. Ooh. So we've got to figure out what's happening between these two x-intercepts and these two x-intercepts. We already know what happens to the far left and the far right. We know that our graph goes down and up. So to the far left, it's going to go down. To the far right, it's going to go up. And we need to figure out what happens in between. So for our next step, you are going to, I guess we didn't find our y-intercept up here. Yes, we did. Just kidding. For our next step, actually, wait, we don't find the points in between. We find our y-intercept. My bad. I want you to find the y-intercept. So remember, use x equals 0 and find that y-intercept real quick. Press pause and then press play when you're ready to check your work. All right, so for this y-intercept, I found it will happen at 16,384. And I'm gonna actually wait to graph it because I wanna wait to see what happens between my x-intercepts to kind of figure out what I need to label my scale on my y-axis. So let's do step 4 before we actually graph our y-intercept. So remember, step 4 is to find extra points as needed. So make yourselves a little table. For this one, we need to pick some x values between the y-axis and this x-intercept. So I would use like -1. We're going to want a point between the y-intercept and this. So I would just pick like 2. And then you're also going to want to plug in a value between 4 and 8. And I would just pick 6. All right. So plug in those values for x and find your y value. And then plot those points. So go ahead and give it a shot on your own. Press pause and then press play when you're ready to check your work. I'll see you on the other side of this problem. So once again, we get some pretty wild numbers. I got negative 875 for -1. I got 49,152 for 2. And I got negative 52,400. Wait, negative. Oh, I can't read that number apparently. That's funny. It's negative 524,000. 288. Shoot, I didn't count. I guess I didn't go big enough here. Let's see, I need to get to 500,000. Ooh, easy fix. We'll just add a 0 to all of these. Cool. All right. So, let's plot the point. -1, negative 875 is going to be like, it's basically going to be like barely right there. 2 and then 49,000 is right up here. And then 6 and then negative 524,000 is going to be about there. Don't tell anyone I counted differently here. Okay, so it looks like what this graph does. So I actually just realized I made a mistake. And let me tell you why. I'm going to tell you why I know I made a mistake. I got the wrong value for -1 here. So if ours doesn't match, that's a good thing. Y'all probably caught that. I actually should have gotten 1,125. And here's why I know I made a mistake. Because if this had been correct, that means that I would have to go down and then cross the x-axis again to get back up to the this y value up here. But I don't have an x-intercept over here, so I shouldn't be crossing the x-axis. So that's how I was like, wait, something's wrong with this value. So then I realized in my calculator, which you can see, I did +8 instead of -8 up in that very top row. I don't know if y'all can tell, but that's what I did wrong. I should have gotten a positive number here. So hopefully that's something you can kind of like look out for and keep track of yourself. Man, there's a lot to think about, huh? These problems are a lot. I'm willing to admit that. Okay, so it should be up here somewhere. So we're gonna go up to this point. We're gonna come back down to this x-intercept. We're gonna come down here and then go back up to that x-intercept. And we kind of get a picture of what our graph is doing here. There we go. That's it. And again, we knew that our graph goes down to the far left and up to the far right just based on our end behavior. All right, so go ahead and get started on your homework on Schoology. Hit that ask for help button if you need help along the way. I'll jump into your breakout room and work with you. I hope you guys have a good day. See you back in class.